Well, welcome everyone. Thanks for joining me today. Engineering a design system and how we did it. First, let me introduce myself. I'm Luca. I'm an Italian, currently living in London, where I'm an Android engineer working for Triller. For those of you who doesn't know, Triller it's a social platform application focused on music and video sharing. And that's my Twitter handle. I'm not really active on Twitter, but I will post the slides of the show later on today. So if you want to find them, it's there. So engineering a design system. What is a design system? Who knows what is a design system? Raise your hand if you know. Cool. Who actually uses a design system in your work? Is that your design system, like the company's design system, or someone else's design system, like material design system or other design system? Company? Cool. So, well, I'm going to talk about what is a design system, how does it impact the speed and the speed of design and development, showing a comparison between the UI stuff that our design came up with and the code that we did, the problem we faced, where we are right now, and I'll also draw some conclusion at the end. So again, what is a design system? A common thought about a design system is that it's just aesthetic, just few Figma designs, sketches, and that's it. Everything is owned and created by designers, and provided to us developer to use and mirror those designs into our product, being them application or website. And those definitions might encourage this thinking, like a design system is a set of interconnected patterns and shared practices currently organized. A design system is a collection of reusable components guided by clear standards that can be assembled together to build any number of applications. But that's not entirely true. A design system, it's not only aesthetic and graphics and UI, colors, and whatever. A better definition, it's this one. The complete set of design standards, documentation, and principle alongside the toolkit, so UI patterns and code components to achieve those standards. And as you can see from this definition here, the code is actually mentioned. So yeah, again, a design system, it's not just aesthetic, it's implementation, code, everything all together. And as an example, the material design, which is a design system, doesn't only come with aesthetics, so with designs and components, but also with a develop and resource sections as well. And in those two last sections, I believe that nowadays you can see examples of code and implementation on how to implement the design system. And the supported platform should be web, Android, iOS, and Flutter nowadays. So, what are the advantages of a design system? First of all, consistency. Once the design system is in place, it's really easy to have consistency across not only one product of the company, but all the products of the company, if the company has more than one product. You get higher quality. This is because once the design system is in place, you don't really need to focus on code quality, test coverage, and whatever, but you can actually focus on the end product, so what actually the user is going to be using. Faster builds. No, not talking about Gradle builds. Unfortunately, those are not affected by a design system. But again, as you don't need to pay too much attention to small details, you can reuse components that you already created, and this also speed up the designment of new user story or screen or user journey inside your product. Improve maintenance and scalability. Here again, as it's a system, if you need to change something, it's going to be done in just one place and reflected all over all the products that your company is using. Stronger focus on product. Again, you have to concentrate, you can concentrate on solving user needs instead of paying too much attention on standards inside the code, rules, designs, views, fancy UI, and whatever. And it also creates a better communication between teams, and this is especially true between designers and developers, and also especially true during the first phases of developing a design system. But there are some disadvantages as well, like it takes a huge initial effort because you need to build everything from scratch. You would, from our perspective, the developer perspective, you still would need to build the activities, fragments, views, and whatever, but you might want to build them with scalability, more flexible, open to extension for later use. So you might need to invest some more time in building the design system. And you're less flexible. As I say, the design system is a collection of rules as well. So once you have those rules set in place, you can't really do whatever you want and ignore those rules. Now, in our company, we're using an atomic design system. Atomic design systems are based on the chemistry of materials. So the building blocks are atoms, which are the smallest and simple components of something. You can split an atom apart. And a collection of atoms builds molecules, which are a group of two or more atoms altogether. Those molecules then combined all together form organelles or components, and those components have their own meaning and purpose and can be split apart without losing this meaning and purpose or their function. Then you can organize organelles all together to create templates and pages, being them web pages or activities, fragments, user story, user journey, and whatever. So one core components of design system, it's a color palette. So the definition of all the colors that a design system and all the products of an application will use in a proper way. Another thing is typefaces, so fonts, sizes, and all the collection. Those two all together creates the branding of the product and company as well. This one is a bit controversial. Not every design system uses a grid system, which is basically just the definition of all the possible sizes to be used across the entire collection of products, usually for margin, paddings, dimension of buttons, and whatever. This is taken from the Material.io guidelines, and the material design system uses a baseline grid system based on 4dp and 8dp, whereas us, we're using a grid of 8. We allow every multiple of 8 and a few smaller values as well. Now, atoms. Everything you see on the screen are atoms in our company. As you can see, we can have images alone, labels with different font, sizing, and colors as well, and icons / images. For example, the dot, which can be enabled or disabled, and this, for example, would be considered a molecule, as it's a combination of small atoms. And altogether, we combine all those atoms and molecules to have a component, which in this case here, it's a banner to showcase challenges that we're displaying in our app. This is another component, and it's built from a few atoms. Can you spot them? Well, it's pretty easy. We have an image, which actually, it's not entirely an atom, because it's more of a molecule, as it comes with the profile image and the white circle around it. Here again, molecule, username, it's a label, so that would be one atom, and the icon would be another one, forming a molecule. This is an atom, profile name, and this is a molecule as well, as it has a button, but also a custom shape as a background to round the corners. Now, we try our best to have a one-on-one comparison / similarity from designs in Figma and what we do have in the code. So for the color, we created this color palette XML file where we defined all the color that we could use inside our app. I haven't listed all of them here, but this is the only file that we allow to hard-code colors in. Everything else in the code, being it XML file or Kotlin, can't hardcode any color, but has to reference one of them. For the fonts, we are relying on the text appearance of the framework and styles attribute. So we defined all the attributes that a label can have, and here we kept a one-on-one comparison with our designs in Figma, because there's a fancy plugin that allows you to copy the style from a label and extract it into XML code, which you can then easily pass in your XML layout. For the grid system, we had a similar thing for the color palette. We have a dimension grid sizes, where we defined all the sizes that we're allowing into our app. And again, every other file usually has to reference one of those. We also have the same thing for the fonts, for the text size. We're using basically the same values, but in SP instead of DP. And for the atoms, we relied on the styling of the Android. So we defined every aspect that an atom would need. So for example, a label or a button inside the styling of the Android framework. And then we simply apply the style on a framework view, as we're doing here. This actually would be a molecule, as we're also setting an icon on it. And what about components? Or what did we came up with? Well, we used widgets. And we had a look around to the latest technology. We had a few ideas. We copied something from the reactive frameworks that we have. So React Native, Flutter, and the latest two, Jetpack Compose and Swift UI. We got the name from Flutter, but that's all we got from Flutter. We're not drawing on canvas for every of the widgets that we have in our app. We didn't went so crazy in optimization. So we wanted to have reusable components that would allow us to use the same components over and over in our app and slightly customize it as needed. And as you can see from this layout here, we have 2 or 3 components that we're using, or widgets. As I said, we wanted them to be slightly customizable and or configurable. So we are using the declare stylable XML tag in order to set what can be customized in every single widget that we have. And here as well, we try to keep consistency between what a component in Figma that our designer have can be customized upon and what we allow our app to be customized upon in that specific widget. So To have consistency between all the widgets that we have in our app, we came up with two interfaces, a widget and a widget.state. The widget is a typed interface that exposes a render function which accepts its inner state. And this is an example. This is the smallest and easier widget that we have in our app so far. As you can see, it extends the widget interface, providing its own internal state, which in this case, it's just a data class that holds a value. And it overrides the render function in order to load the text inside the view that it has. It also extends a view group, in this case, a frame layout, and that allows us, as I showed before, to use those widgets inside the XML file. But we can also create them at runtime and inject them into a view. And this is how the render function would look like from the outside. You just tell the widget to render, providing an instance of its state. That string resource you see there, it's an interface that we came up with in order to detach the actual implementation of setting a string, being it a resource ID, a char sequence. I think that we also allow spannable strings and strings with varargs as parameter. Both, we wanted it to be detached both from the widget and from who's using those widgets. So as you can see here, we are not getting the context.getString to load the text inside of it. So we immediately faced a controversy. Do we want small components, really easy, and few lines of code, as the one you just seen, or do we want bigger components, more purpose, more configuration available for every widget, and so on? Initially, we went with bigger components, and we kept adding configuration over configuration on one widget especially, and we came up with a state like this one. And the render function, as we're using code climate, we had to split it because otherwise code climate would complain about code complexity in just one function. So, no thanks. We thought about using sealed class here as well, instead of an enum inside of the class in order to split how it was rendered, but it wouldn't change much. So we had a poll, we had quite a long discussion about it, talking about boundaries, rules, what should we use, when and how we should split a widget into different ones. And we eventually ended up reverting everything and going for small components, even maybe duplicating some code, but single responsibility widgets, easier to understand, easier to write, easier to debug as well. So that big class that you've just seen became two of them, and we later added, also the render function became more easier and smaller, and we ended up with two widgets and then with another refactor, we removed the possibility to change the background resource and the title color at runtime from the render function, leaving them only as configurable in an XML file. And this is one of those two widgets that we actually split. As you can see, it's slightly customizable as we're setting the title of the row widget, but that's all. Everything is used by default. And this is another instance of the same very widget, but here we're setting a slightly different background. It has a subtitle, and we tell the widget to hide the separator as it's being used at the top of a view. And this is the other widget instead, which is an editable row widget, which results in something like this. So it's a label, it's a row which has an editable in it, and the two below it instead are the other widgets, so the label widget, no editable there. I took those 2 slides from the Jetpack Compose website, and so we provide the state, as you have seen, from the outside into the widget. And for example, the previous one is an editable one, so we needed events to go backwards to bigger components, and we use listener for that. Nothing really special here. We have different listener in a widget, and from the outside you just set the listener in this way. I need to speed up a bit. Sorry. Well, this is nothing really outstanding, just how we set the listener. We're using nullables, so we're allowed to safely invoke those listener or not. And this is the end result. Actually, no, sorry, this is a completely different widget, which is a more complex widget built upon different, smaller widget. The state starts to get big, but as you can see, it just basically tunnels the value of part of the state into smaller widgets that it's using internally. So the only real value that this widget is using by itself, it's the notification type. And this is the XML file of that widget. As you can see, we have 2 other widgets inside of it, but also material view, native view. This widget here, it's the one I showed you earlier, the user with username, surname, and the button at the end. This is one of these smaller widgets that we had inside of it, and as you can see, the render function just render things on native views, and this is the other one, so the 2 labels. Another thing we came up with, it's the dev app, what we call the dev app. This is a side app that gets installed whenever we install the development build variant of our app. It has a few sections inside of it. One of them is the typeface, which showcases every type of label that we can have in our app, with sizes and fonts as well. And the other thing, which is the most important thing in that app, it's the widget section. We have a collection of all the widgets that we have built for now, and tapping on one of them will just show the widget and all its possible configuration. So we don't have to go back into the channel when we have a Figma design and ask if we have something in place already to build something like this, because you just go into that app, scroll through there, see what the result is, and just basically reuse that widget if it's in place. Yeah, just showcasing a few widgets that we have in this app. All the widgets, if they have to, are interactive. So that app doesn't only help us as developer, but it helps us also QA and designers as well. We build widgets before actually starting to use them in our app, so designer can install that app, go through all the widgets and the latest that we created, and give us feedback even before we actually start using those widgets in production code. And it also helps the QA, because they can have a side-by-side comparison with a widget which is approved by designer and what we're using in our app. So the current state of our app, as you've seen from the previous layout as well, it's a mixture of our widgets, but also native views. Again, we didn't reinvent the wheel. We're not drawing on everything on canvas, and those 2 are just 2 more examples of layouts that we have. This is a side-by-side from Figma designs on your left and result on your right. I was using a small emulator, so sizes are not perfect, and also different text, which extended and forced the button to be smaller. But as you can see, we're not pixel perfect with our designs in Figma, but those results are approved. You can actually see the last one. Approved by designers, so QA doesn't need to really look at Figma, but they should look at our result in that app and compare that with our production app. What about the future? Well, we're trying to build more and more components, but we don't want to reinvent the wheel again. For example, for a material button, we don't want to build a widget if it's not needed, or for an image view, again, we don't want to create something that complicates and over-engineer everything. And that's what we're gonna do. Hopefully, right now, we reach a state where we're allowed to speed up the development of new feature, new user journey in our app, since we invested a few in building our widget system. Well, special thanks to those 4 people which helped me a lot in creating the slides and coming up with this presentation. That's it.